Hi, welcome to the section of the Matrix Algebra Tutor, and in this section we're going to tackle the topic of what's called Cramer's rule, and it's just a method of solving systems of equations that uses determinants. That's really all it is. So we've learned lots of different things in this class. We've learned about the row reduction, we've learned about how to multiply matrices, we've learned how to do the Gaussian elimination, the Gauss-Jordan, we've learned about inverses and how to use inverses to solve systems. We've learned about determinants. Now we're finally going to use determinants to solve systems. It's just another trick in your tool bag. Sometimes it'll be more advantageous to use this over another method. So the easiest way to do it is just to dive into what Cramer's rule is. It's not very hard. Basically, you're going to calculate a few determinants and start dividing them by one another, and then you're going to find the answers to the variables you're trying to solve for in the system. That's basically what Cramer's rule is. Okay. So let's say for a two-variable system, in other words, a simple system with x and y, because we always start off with two-variable systems to make it easier to understand, then what you would have in general, if you were going to write down your equations, okay, without putting numbers there, what you would see in your book a lot of times, a1 times x plus b1 times y equals c1, okay? And you might also see a2 times x plus b2 times y plus, equals c2. All this means is instead of giving you an example with numbers, you just start by having letters. So you have a number in front of x, a number in front of y, a number on the other side of the equal sign. The 2's and the 1's just mean they're different numbers. So this is a different number, different number, different number. It's just a general way of writing down the system, okay? So what you need to do to understand Cramer's rule is you have to make some definitions. So I'm going to define the following things. And I'm not going to prove Cramer's rule to you. It's just like everything else in the world at this level. I mean, you learn it and you're not always given the proof of it. I mean, that would just bog us down to no end, okay? So what I'm going to define is a determinant called big D. And that determinant is going to be the determinant of the coefficients on the left-hand side. So it's the determinant of A1, B1, A2, and B2. Basically, it's the determinant of kind of what you would expect you'd take the determinant of the left-hand side here. Okay, that's called D. No big problem here so far. I'm just defining the determinant of the left side of the matrix, and you know how to calculate that using your little x there. Okay. Now also, I'm going to calculate, or I'm going to define actually, D sub x, determinant with a little sub x here, and that's going to be defined as you basically take your D that you defined here, and because you're defining sub x, here are the coefficients. The a's are the coefficients in front of the x. So wherever these are, you replace them with what's on the other side of the equal sign. So you're going to have c1, c2, b1, b2. And you define that, and you calculate this determinant. You call it d sub x. The reason, again, it's sub x is because the a's here are the coefficient in front of the x's. You replace these with what's on the right-hand side of the equal sign. This stuff stays the same. You also define a d sub y, which is a similar thing. You have A1 here and you have A2 here, but the coefficient of B here is in front of the Y, so you replace these guys with what's on the other side of the equal sign, C1 and C2. Okay? So once you get past wrapping your brain around that, the actual math is not that hard. You have to define a D, which is this determinant over here. D sub x replaces these coefficients with what's on the other side of the equal sign. D sub y replaces these coefficients with what's on the other side of the equal sign. You calculate three different determinants. Okay? So then, the grand finale of all this stuff is very simple, actually, once you calculate these determinants. The value of the variable x for this system of equations is just equal to the determinant x you calculate, which is a number, by the way. Determinants are always numbers, divided by determinant d, this one up here. Okay? And the variable y is equal to determinant sub y divided by d. Okay? This is called Cramer's rule. And it's pretty cool when you think about it because you're solving the system not by row reduction and not by inverse matrices. You're using it purely with those determinants. And between you and me, I think calculating determinants is a whole lot easier than calculating a matrix inverse. Or even doing all that row reduction a lot of times is much, much easier. Even if you're doing a 3x3 determinant, it's much easier with me with the little x's doing that than it is calculating the matrix inverse. All you need to beat in your head is what dx and dy are, which is just replacing the coefficients of x and y with what's on the other side of the equal sign. So once you get them, you just take the quotient of d sub x divided by the total determinant, d sub y divided by the total determinant. You're going to get two different numbers. This is the values of x and y that satisfy the system. So keep that in your mind. We're going to do that in your head now, in a few examples here as we go. Now what I want to do next is show you what Cramer's rule looks like for a three-variable system. So for a three-variable system, it's generally really the same kind of thing. It's just that I want to write it down for you so you're not confused. In general, if you were going to write down a system of three variables, x, y, and z, then you would have a sub 1 times x plus a sub 2 times y plus, let's call it b sub 1 times y plus c sub 1 times z is equal to d sub 1. Okay? These are just letters of the alphabet to represent numbers. A sub 2 times x plus b sub 2 times y plus c sub 2 z is equal to d sub 2. Okay? A sub 3x plus b sub 3y plus c sub 3z is equal to d sub 3. Okay? So that's a system of equations in three variables. Now how do you apply Cramer's rule? It's really exactly the same thing. You just got to be a little careful. The big D, the big matrix, is just a matrix of what's on the left, just like before. A1, B1, C1, A2, B2, C2, A3, B3, C3. Determinant. That's it. That's D. Okay? Now when you're calculating D sub x, all you do is you say, well, these are the coefficients of x, so I replace them with what's on the other side of the equal sign. So I'll have D sub 1, D sub 2, D sub 3, and then the rest of the matrix stays the same. B1, C1, B2, C2, B3, C3. Okay? And if you're going to look at dy, which you're going to have to know, it's going to be the same thing. You look at your matrix, you take the coefficients of y, and you replace them with what's on the other side of the equal sign. So you have A1, A2, A3. Replacing these with these, you'll get D1, D2, D3, and then the rest of the matrix stays the same, C1, C2, C3. Okay? And it's a determinant there. And then you'll have to define, since you have three variables, D sub z, which you see the pattern here. All you do is you take the coefficients of z and replace them by what's on the other side of the equal sign. So you have A1, A2, A3, B1, B2, B3. Replacing the c's with what's on the other side, you'll have D1, D2, D3. Now all of these are determinants. So what you'll have to do is calculate the determinant of dx, determinant of dy, determinant dz, and of course determinant of the big one up at the top. And once you define all of those things, then Cramer's rule states that the variable x you're trying to solve for is d sub x over d. This is a number. Remember, determinant is a number divided by d, which is also another number. Y is equal to d sub y over d, and z is equal to d sub z over d. So once you calculate the determinants, which are infinitely easier, I think, than finding the inverses, you just have to start dividing them to find the variables that you care about. So let's go ahead, knowing that the pattern between these two things is really the same between a 2x2 and a 3x3, and the pattern would be the same if you go up to 4x4 and on beyond that. Let's go ahead and work a couple of problems in practice. Okay, so for our first problem, let's go ahead and see if we can figure out how to solve this guy with Cramer's rule. X plus 2y is equal to 19, and let's say 3x minus 7y is equal to negative 8, and we want to solve this using Cramer's rule. So the first thing we need to do is define our determinant of what we call big D, right? Which is the coefficients on the left-hand side. So 1, 2, 3, negative 7. So we're going to calculate that. We'll do it here in a second. We're not going to do it right now, just because I want you to get the flavor for the big picture. D with the sub x is going to be this matrix, but the coefficients that relate to x are these right here. We're going to replace it with what's on the other side of the equal sign. 19, negative 8, 2, negative 7. We're going to find that determinant. And then we're going to find a dy. So we're going to take this matrix and the coefficients that deal with y, which are these, we're going to replace with what's on the other side. So 1, 3, 19, and negative 8. Okay, now we're in a good position to actually calculate determinants. Okay? So let's go ahead and do that now. Over here, what you're going to have, just using your x like this, you're going to have 1 times negative 7 minus 2 times 3. Okay? Minus 2 times 3. And so what you're going to have here is you're going to have 1 times negative 7 is negative 7 minus 6. And so what you're going to have over here is you're going to have negative 13. For that first determinant up there, you're going to have negative 13. Okay? Now for this one, doing your x like this, you're going to have 19 times negative 7 minus, doing your x this way, 2 times negative 8. Okay? Now 19 times negative 7, in calculator, negative 133. Negative times negative gives me positive 16, and when you actually take negative 133 plus 16, you're going to get negative 117. Okay? So let me go ahead and circle kind of important points here. This is the determinant we care about up here. This is the determinant that we calculated right here. And for the final one, doing our x, 1 times negative 8 minus 19 times 3. Okay? 1 times negative 8 is negative 8. Minus 19 times 3 is going to be 57. And when you take negative 8 and subtract 57 from it, you get negative 65. And that's the third piece of information we need. So because it's a 2 by 2 system, we have only had to calculate the determinant of 3 matrices. It's not that, much math here. It's certainly not nearly as hard as the inverse stuff. The value of the variable x that we care about is going to be dx over d. dx we calculated was negative 117. D we calculated as negative 13. So when you actually do that, negative divided by negative is positive, and that 117 divided by 13 is going to give you 9. Okay? And then y is going to be dy over the determinant d. dy we calculated here is negative 65, and d was negative 13. And so when you actually do that, 65 divided by 13, you'll get positive 5. Okay? So you calculated x and y, and that's exactly what you wanted. That's the common point to these two lines, really, because it's a 2 by 2 system. It's just some lines that cross at this value, this point here. You just had to calculate a few determinants. Now, you could have done row reduction. You could have done some other stuff, but I start off with an easier problem to kind of illustrate sort of the big picture to you. Okay, so for our next problem, again, we're going to start off with some easier problems. So 2x plus 3y is equal to 7, and 5x minus 7y is equal to negative 3. And we need to find the solution to that using Cramer's rule. So the first thing you want to do is you want to define your matrices. So matrix D is going to be the coefficients here, okay? And that's going to be 2, 3, 5, negative 7. Okay? dx is going to take this matrix, and the coefficients that deal with x, we're going to replace it by what's on the other side of the equal sign, which is 7, negative 3, 3, negative 7. Okay? And then finally, d sub y is going to, again, take coefficients relating to y, replace them with these. And so what you're going to have here is 2, 5, 7, negative 3. 2, 5, 7, and negative 3. So now we're in a good position to actually calculate the determinants up here. And so what you're going to have using your x is 2 times negative 7 minus 3 times 5. Okay? So what you're going to have over here, 2 times negative 7 is negative 14 minus 15. So negative 14 minus 15 is negative 29. Okay, negative 29, and that, I'm going to go ahead and circle it so you can remember that's one of the important pieces of info we need to hang on to actually finish the problem. Okay? This guy, to calculate it, going with an x, 7 times negative 7 minus, going this direction, 3 times negative 3. Okay? And finally, doing the math here, 7 times negative 7 is negative 49 plus, because negative times negative is positive, 9. So negative 49 plus 9 is negative 40 right there. And we want to go ahead and circle that because that's going to be important for the final solution. Finally, calculating this dy using our x, you're going to have 2 times negative 3 minus, going this way, you'll have 7 times 5. 7 times 5. And so 2 times 3 is 6, so you have negative 6. Minus 7 times 5 is 35. And what you'll see is negative 6 minus 35 is negative 41. And that's the third determinant that we need. Now, once we have that information, then the variable x that we're trying to solve for is dx over d. Okay? D sub x we calculated to be negative 40. And d we calculated to be negative 29. Okay? So 40 divided by 29, you really can't do too much with that, so we just cancel the negatives and we say that it's 40 over 29. That's the answer for x. And then for y, we just say that that's dy over d. dy we calculated as negative 41. The other d is negative 29. Okay, there, you really can't do much with that either, so you just basically cancel the negatives and you say it's 41 over 29, and that's the answer there. So that's, again, how you use Cramer's rule when you're dealing with a simpler two-variable system. You define your determinant of your coefficients, and then you calculate some other determinants related to replacing some of these coefficients with what's on the right-hand side, calculate them, do some divisions, and you get the answer. Now we're going to go ahead and work a problem with the 3 by 3 matrix, which really follows exactly the same form. It's just that the determinants take a little bit longer to calculate. Okay, let's say you were tackling a system that was x plus y plus z is equal to 0, and 2x minus y plus z is equal to negative 1, and negative x plus 3y minus z is equal to negative 8. This was your system of equations. Now, basically you're going to end up calculating a lot of determinants and just going from there. So let's do that. So the first determinant, the big D, is just going to be the determinant of everything in the coefficients over here. So you're going to have 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1. Those are the coefficients there. We'll calculate it in just a moment. Okay? These are the coefficients here, and let's go ahead and calculate this right now. So what we need to do to calculate that is we need to go ahead and write that down as follows. Remember, we start with the 3 by 3. We start with the first column, 1. Then we take the determinant. After we cross out these rows and columns of what's left over. So we have negative 1, 1, 3, negative 1. We have to take the determinant of that. Okay? We have to put a negative sign for the next term always when we're doing this. And we'll have a 1 times the determinant of, after you cross through these, whatever's left over. This, and these numbers right here. So you have 2, 1, negative 1, negative 1. Okay, and you have plus, the third one is a 1, and you cross out this and this, whatever's left over is 2, negative 1, and 3. Okay, 2, negative 1, and 3. And so let's go ahead and do that math right there. So what we're going to have here is, going this way, negative 1 times negative 1, okay, minus, going this way, 1 times 3. Minus, because of this, we calculate this determinant going this way. 2 times negative 1 minus 1 times negative 1. Going like this and then like this. Okay? And then for the third one, I'm going to have to move down here, plus what we're going to have over here is going like this. 2 times 3 minus, and then going this way, negative 1 times negative 1. Okay? We're going to have that. And that's going to basically be what we have there. And then to continue on, what we're going to have in here, this is going to be positive 1 minus 3 minus, and on the inside here, you'll have negative 2 minus 1. Actually, it's going to be a plus 1. Negative times negative gives you a positive. And then over here for this term, you're going to have on the inside 6. This gives you a positive 1, but you have a negative, so it's negative 1. Okay? So here, 1 minus 3 gives you negative 2, minus, over here, you're going to have negative 1, and then over here, you're going to have 5. And what this is going to amount to here is negative 2 plus 1, distributing this in, plus 5. And then finally, you're at the point where you can actually do this addition. Negative 2 plus 1 is negative 1 plus 5 is positive 4. Okay? So what you're going to have is positive 4. So what I'm going to do at this point, because I'm going to quickly run out of board space here, is this determinant, we've done this math and we got a positive 4. So I'm going to put an equal sign and put a 4 here because that's the determinant that we calculated using this math right here. So make sure you understand this before you move on, because I'm going to erase that right now. Otherwise I'm going to quickly run out of the entire board calculating this, because I'm going to have to calculate, I should say we are going to have to calculate a dx, a dy, and a dz, because you have 3 variables, right? So what we're going to have for d sub x is we're going to take this matrix that we have here and we're going to replace it. These coefficients of x we're going to replace with what's on the right-hand side of the equals. So negative 0, negative 1, negative 8, 1, negative 1, 3, 1, 1, negative 1. We're going to take the determinant of that. Okay? So the way we're going to do that is we're going to put a 0 out front because we're starting with this. And on the inside of that, you know, we've marked through this guy, we've marked through this guy. So what we need to do, effectively, is we're going to be taking the determinant of what's remains, which is over here. Negative 1, 1, 3, negative 1. Like that. Now we're going to move on to the second term. You always put a negative, and you have a 1 out front here. And so you mark through this column and this row, and what's left are these guys. So you're going to take a determinant of that. Okay? And finally, for the third one, you're going to have a 1 out front, and you're going to take the determinant, when you mark through these, of all of this here. So you have a negative 1, negative 8, and a 3. And you're going to have the determinant of all of that stuff right there. Okay? So to calculate the determinants, this is going to be a big fat 0, so I'm not even going to worry about it. Okay? What you're going to have here from the negative 1, this is going to be a negative out front, and inside you just go with your x. So you're going to have negative 1 times negative 1 minus 1 times negative 8. Okay, like that. And then over here you're going to have a 1 outside, so you're just going to have on the inside taking this determinant, you're going to have negative 1 times 3 minus negative 1 times negative 8. Okay, just like that. Negative 1 times negative 8, okay? And then when you actually start simplifying it, what you're going to have is you're going to have this negative sign out here. This is going to give you a positive 1. This is going to give you a negative times negative is positive 8, okay? So you're going to have a 1 plus 8 there. And then over here, you're going to have a plus. And then over here on the inside, negative times positive is negative 3. This gives you positive 8, but it has a negative in front, so it's negative 8. You have negative 3 minus 8. So what you're going to have here is you're going to have negative 1 plus 8 is 9. And then over here, negative 3 minus 8 is negative 11, so you have minus 11. So negative 9 minus 11 is negative 20. That's the determinant of d sub x. So what I'm going to do here, we've done this math to calculate that determinant. I'm going to go ahead and write it down over here as negative 20. Okay? Go ahead and write it over there as negative 20. Okay, so in order to save board space, I'm going to have to erase that we just calculated. Okay? And we're going to have to move on to calculate d sub y. Okay? D sub y is going to be equal to this original matrix, but with this column, because it's the y column, replaced by what's on the other side of the equal sign. So what you're going to have is 1, 2, negative 1, and replacing this, you're going to have 0, negative 1, negative 8, and then over here you're going to have 1, 1, negative 1. Okay? Now let's go ahead and calculate that. Just make sure we're doing everything right. So we just take it step by step, doing our determinant like we always have. So you start with the first guy, which is a 1, and you mark through his column and his row, and everything you have left, you take the determinant of it. So let's just go ahead and do that now. Doing an x like this, negative 1 times negative 1 minus 1 times negative 8. Okay, just like that. Okay? And then what we're going to have is negative, because you always have a negative for your second term, 0 times the determinant here. Now you're going to mark through this and this. The only thing left is this stuff here, so you take a determinant like this. 2 times negative 1 minus, going this direction, 1 times negative 1. Okay? Like that. But in the end, it's really not going to matter at all because I have a 0 out in front. And you add to that this 1 here. You're going to mark through this and this. The only thing you have left is this. So 2 times negative 8 minus negative 1 times negative 1. Okay. So what we're going to have here on the inside, negative times negative is positive 1. Minus times minus gives me positive 8, so you have the same sort of thing as before, 1 plus 8. This is all going to be a 0, so we don't even do anything with it. Plus, and then over here, this is negative 16. This is positive 1, but you have a negative, so it's negative 1. So you have negative 16 minus 1. So in the end, you have 9 here plus negative 17, so it's negative 17. So then you have 9 minus 17, which is negative 8. That's the determinant of dy, which I'm going to put here as negative 8. Now really I'm at the bottom of the board. I don't need to really erase this anymore. Let's go ahead and calculate d sub z, and then we can finally solve this problem. Okay, so d sub z is going to basically be the determinant of my coefficient matrix from over here, but with this guy replaced by this over here. So let's go ahead and write it down. You're going to have 1, 2, negative 1, 1, negative 1, 3, and then replacing this by this over here, you have 0, negative 1, negative 8. Okay? And want to calculate that determinant. So let's do that. First thing we're going to do is we're going to have a 1 out here. We're going to mark through these guys here. We're going to take the determinant of what's left over. So we're going to have negative 1 times negative 8 minus, going this way, negative 1 times 3. Okay? So that's done. And what we're going to have is we're going to subtract off, because we're doing a subtraction for the second term, 1. Now once we do this, we're going to mark through this column and this row. The only thing left over are these two numbers and these two numbers. We're going to take that determinant by doing an x, just like this. 2 times negative 8 minus negative 1 times negative 1. Okay? Now technically you're going to have a third term because you're going to have plus 0, and you're going to have some more determinants here, but it's really just not going to matter, so I'm going to leave it blank because you're going to have a 0. It's going to make the whole thing go to 0 there. Okay? So what we're going to have at the end of the day is we're going to have positive 8 here. This makes a positive 3, so plus 3. You're going to have 8 plus 3. And then you're going to have a negative sign, and over here you're going to have negative 16. This is positive 1 with a negative makes it negative 1, so you have negative 17. So what you're going to have is positive 11. This is going to be negative 17, but with a negative sign out front makes it positive 17. Okay, so you have 11 plus 17 is going to give you 28. And that is the answer for d sub z is 28. So I'm going to go and write positive 28 here. Okay, now finally, after all of that, we can actually solve this problem. The variable x that we're looking for is going to be equal to d sub x over d. D sub x we calculated as negative 20. D was 4. Okay? So that means x is equal to, 20 divided by 4 is 5, so it's negative 5. That was the value of x, was negative 5. Okay? Y was equal to d sub y that we just calculated over d. D sub y we found to be negative 8. And the big D that we found before was over 4. Okay? So y was going to equal to negative 2 here. Y was equal to negative 2, and that's correct. And then finally, for z was equal to d sub z divided by d. Okay? And d sub z we just calculated as 28. D, of course, from before is just equal to 4. And since 7 times 4 is 28, z is equal to 7. So this is basically Cramer's rule for a 3 by 3. You start with your system, you define your big D matrix with your coefficients, define dx and dy and dz, find those determinants, and when you find them all, it's a simple matter of dividing dx divided by d for x, y by d for y, and dz by d for z. So that was the topic of Cramer's rule. I know it gets a little bit messy and a little bit not fun, but it really isn't that hard after a while, because determinants are tedious, but not nearly as tedious as inverses and some other things you have to deal with. So you define your d, define your dx, dy, dz if you have it, and divide them appropriately, and you go ahead and calculate x, y, and z, and that is how you solve a system of equations using determinants and specifically Cramer's rule.